This is today for us an exciting day. And as you guys mentioned earlier before the live streaming started, another Israeli company, another storage Israeli company is launching. So 3 years ago when we all started, me, 20 years of storage experience, it was really important to try and build a company that is going to change the storage industry. Many years with TDN, EMC prior, you know that there's such a dense market that you really need to come with a special story. And we decided to wait with that story. This is almost 3 years since it started, 2.5 years since we incorporated. Some news about us here and there, but today is our day. I must say, on a personal level, I'm excited. The guys are excited. So we apologize. It's my first tech field day. I'm happy to say tech, since it will be mostly about technology. As the CEO, I'm going to be quiet, listening, and saying thumbs up. So again, thank you. WeWork facility here in San Jose is hosting us, and we thank them for that as well. This is quite a nice room. As for the speakers, you guys all got. So the speakers today will be Yaniv Romem, our CTO, one of the co-founders. We'll talk about the technology, about the market and technology. Then we'll have Josh to show you the use cases and a live demo of the product. And we also asked Yuval Bachar from LinkedIn, who is also leading Open19, to come and talk about hardware innovation, which connects to the innovation we're doing with software. Overall, it should be an exciting day.
Thank you, Lior, for that. Okay, so my name is Yaniv Romem. I'm CTO for Excelero. I'm extremely excited to be here. I hope it won't be conveyed too much, my excitement. But I am really excited to be here. I'm one of the co-founders. We started the company 3 years ago, like Lior said. Just going through the agenda, I think Lior actually did most of that, so I will continue. Okay, just a short corporate overview before we dive into the details of what we're actually doing. So what are we trying to do to begin with? When we set out, what was our objective? Our objective is essentially to enable businesses to build their own high-performance scale-out storage infrastructure. We're providing the software layer for that. We're not providing the hardware, but what we want to do, what we're building, should enable businesses to go and generate a very high-performance storage layer that will serve their application needs. It should be performant enough to basically meet the needs of any application. It should provide the building blocks to allow you to bring in any hardware that you want and to transform that into that kind of storage layer. As Lior mentioned, the company was founded 3 years ago. It was originally founded in Israel by ourselves and a couple of other technical co-founders. Since we have moved headquarters to the US, headquarters are now here, as you can see. We are well funded. We've been through 2 rounds of financing. The more recent one was led by Battery Ventures, who have a strong affiliation with storage companies. David Flynn did some of the technical due diligence on their behalf, and he decided to co-invest, something which we are very proud of. We are heavily biased towards intellectual property. We have applied for 11 patents to date, one of which has already been granted by the USPTO recently around a technology called RDMA, and we'll dive more into that as we progress. As you can guess from the name, it's a knockoff. It's very similar to something to RDMA. It does what RDMA does for memory, it does for drives. Due to our mission statement, our target markets are places where there are large data centers which have need for a high-performance storage to support their scale-out applications and their scale-out needs in general. As such, our target markets are the web scalers, the cloud service providers, financial institutions of various sizes, HPC, federal. Wherever you'll find a large data center, you'll probably find Excelero applicable. We have a very strong inclination or program for working with partners. Some of the partner logos below are companies that we are working with, some more formally, some less formally. As a software solution, we are working with the hardware vendors to ensure that our product is certified or validated on their hardware and also optimized for it as much as possible. We've had some initial revenue success, initial traction with customers, and those are the logos that are showed here. There are others, but these are the ones that we're allowed to show. So where did it all sort of start out, or what gave us inspiration to do what we're doing? we were looking at the storage market in general. We're very much aware of the way the world is moving from monolithic applications to scale-out applications. And we looked at what the big guys were doing, how they were handling that. And the big guys, we mean the companies that are building out scale-out infrastructure. And we sort of sat back and when we say the big five, we're talking essentially about the American ones, Microsoft, Amazon, Google, and Facebook and Apple. And we said, well, how are they building out their infrastructure? I mean, what are they doing? How are they making it possible to run scaled applications in their environments? And we found that essentially there's some almost philosophical elements within their architecture that are applicable also for storage. So they're using standard hardware. They're not bringing any specialized hardware in. They're really optimizing everything for efficiency, the compute layer, the networking layer, the power layer. I think Open19 is sort of the pinnacle of that to a large degree. And Yuval will discuss that later. And then they're layering on top of that, they're layering intelligent software to go and put it all together to compensate for any specialized hardware that they should have been using or they would have been using in previous data center worlds. But they've been really opted out for efficiency. And you end up getting something called the software-defined data center. So the data center is built of the most optimized hardware, but the software on top of it is really what defines it and turns it from pieces of hardware into a data center, so to speak. What are the trends, the storage market trends, or what are the trends that we saw that invoked us to go and do what we're doing? So the first part is applications have been moving to be scaled out applications. And as such, they require a storage layer that will match their needs. So I think it's been recently coined by one of the analysts as something called shared accelerated storage, and that really, in a way, defines what those applications need from a storage perspective. You need storage that can be shared among multiple nodes, multiple instances. Consider an application like Siri, which has different instances depending upon the time of day running to meet the different language requirements from it. So you will dynamically, the application will change. You will find more instances of Chinese applications, Siri instances running at a certain hours of the day, and then later at other hours you'll find English. How can an application work? Well, when the storage is not something that meets that. So you need an accelerated storage, a layer of storage that is very, very fast and can meet the dynamicity of the applications running on top. NVMe has come to the market in the past few years. It's really taken off in the data center. It brings with it a very high level of performance. Applications are getting used to getting that kind of performance. And that's another thing that you need to take into account when you're building a storage layer for those applications, that they expect to get NVMe-like performance. What enables bringing that across? How do you share that level of performance across the network and make it into something that can be used by shared storage, by scale-out applications? Well, 25G or its multiples as well are really making it into the market. We expect 2017 to be the year when 25G and its multiples really takes off. And with that is coming RDMA. RDMA is a technical capability that allows you to work at high-speed networking and share data very efficiently between servers. It's very critical when you go to these levels of networking. And we see that coming to the market this year. It's being led by Mellanox, but the other network vendors are catching up and they're coming out with product offerings this year. We won't name names because it's still not stuff that has come to the market, but we definitely see that happening in 2017. And the final piece of it is in-server flash. Flash is being used in the data center. It's being used for these kinds of applications. And by transforming it into what looks like a server SAN, it really does implement the vision of shared accelerated storage. And that's really what we're doing. We're building a software layer that will take hardware and this kind of hardware and leverage it to get highly performant shared storage. So what does our product look like? Our product NVMesh, which is what we're launching to the market today, is basically a software layer that sits on top of standard servers in which there are standard NVMe devices or standard flash devices. We are heavily optimized for NVMe, so we typically say NVMe devices. They could be other forms of devices, but that's really where we get the most benefit from our software. Essentially we pool these devices that are, again, standard devices. You can mix and match from different vendors, servers, and SSDs as well. You put our software layer on top of that, and we'll go more into how you can deploy it, what are the various mechanisms for that. And then once you have the entire pool of storage appear as a single pool, you can go and generate logical volumes on top of that. So you're effectively getting something like a virtual SAN or a virtual all-flash array kind of functionality, but you're using standard components that you choose to use within your data center. On top of that, you can run a myriad of applications. Typically, you have different types of file systems in between the block storage layer that we provide and the applications themselves. The applications, as mentioned, are mainly targeted for scale-out applications, but you can use it for other types of applications that require high-performance shared storage. You can run a shared file system on top of it, which we have found in some customers to be very useful. At other places where the applications know how to scale out and work with local file systems because they have been running in that mode on top of bare metal servers, there's also high applicability. From a vision perspective, so today we are coming to market with NVMesh 1.1. NVMesh 1.1 is a part of the story. We have a longer vision long term, and so we expect to achieve more. But looking at what we achieved already today with the version that we're coming to the market with, so at the applicability level, we are allowing to deploy our product in what is called a truly converged mode. A truly converged mode is one where you can use the same servers both as storage servers and as compute servers, and we'll show later on why our product can do that in such an exceptional way.
And you're emulating that paperwork for a reason?
We are, because hyper-converged implies hypervisors. And you can use us without hypervisors, with or without. It's not something that is part and parcel with what we're doing. We're not providing the hypervisor. It's not that we have places where we used with and places where we used without. It's just not part and parcel with what we do. Our product can scale across a data center. It's very resilient, and because it can distribute the data while still providing NVMe-like performance, making it very effective for storage service delivery. As an infrastructure layer, we are not tying you down to a specific piece of hardware. We are part of that software-defined data center as software-defined storage layer. And our expectation is that you will be able to achieve, by deploying our product, high efficiency and a low total cost of ownership. We have a vision, as mentioned, for how we will take this forward. In future releases, we will come out with things that would be expected in such a product at a data center level, be able to provide quality of service. We'll be able to incorporate additional types of media that are expected to come to market over the next few years. We will support additional hardware architectures. So today we are working in kernel within the hardware. We are working mainly in the Linux environment, but we will come out deploying on new types of architectures that are coming to market. Our services, and we'll mention what services we provide today, we are continuing to enhance them and bring additional storage services within our product. We will work to continue to improve the overall, by improving the efficiency, we will work towards a green data center where you only use the power that you actually require. And then again, what we're doing is really part of a total software-defined data center. We're providing the storage layers, but as we progress, we have plans to integrate with other software-defined elements within the data center to make it more, to get overall fulfillment of storage needs by integrating with things like software-defined networking. What makes our offering unique? And that's something that we will later on go through our architecture and come back and say, we have been able to show that this is really why we're unique. First part is that we're building a virtual SAN, but it's really optimized for NVMe. So in software, we're still able to optimize for NVMe in the sense that we can provide shared storage that is at the NVMe performance level. What does that mean? It means that you can run at hundreds of thousands of IOPS, transfer gigabytes per second across the network into a client that can use it effectively, using 100% software only. So you can really mix and decide which kind of hardware you want to use and get this kind of performance levels consistently on a large scale. We are pooling NVMe across the network. We are retaining local speeds and latencies effectively, and we'll show some performance numbers to back that up. We are enabling converged infrastructure, and that goes back to our RDMA patent. Our RDMA patent allows us to serve out storage from a server and run an application there without them interfering with each other. They don't have to compete on the CPU resources. Why? Because our target side software doesn't require any CPU in order to implement the data path. And that's something, again, that we'll come back to visit, but that's what really allows us to work in a converged infrastructure in contrast to any other software-defined storage solution out there on the market today. Our deployment models are very flexible. You can use us in converged mode, as mentioned, where we have a huge benefit, but you can also use us in a disaggregated mode where the servers there are specific servers that have a lot of dense storage inside them, and you don't necessarily have to spread out your storage across all your compute hardware, and you can still get very high efficiencies in that kind of environment. And finally, it's all about efficiency at the end of the day. One of the things that the Big Five have shown to the world is you can reach efficiency, and efficiency is king at the end of the day to reduce TCO. And that's something that our software, as it can run across a large data center, it can scale linearly. It's very important for efficiency at the end of the day.
Yaniv, you're supplying hundreds of thousands of IOPS per second, and you're not using any CPU?
That's
cycles?
right. That's right. That's our patented technology. I promise to come back to that in the architecture and really prove that point, because it is one of the most important critical things of what we do.
I think so.
Is that the RDDA stuff that you're talking about?
That's exactly it.
Yeah,
Well,
I mean,
We'll see.
if you're software only, the software has to run
Somewhere.
somewhere.
Somewhere. I'll promise to go back into
Okay.
it and show that.
There are caveats about
No,
zero
that-
CPU.
he says he's going to get to it. I'll trust him until.
I will explain how we do
When
it.
he
It's
gets
above
there,
it.
I'll make sure he's honest.
Okay.
We all will.
With that, we're going to go through some use cases, and I'm going to invite Josh to come up and explain those.
Thanks.